So here I've got a visual integrator like we had last time, except this time our function is defined as a function of two variables. So we're going along the x-axis and along the y-axis here so that you can see the height there in 3D. So I've got my data points up along here, and then I've got my Riemann strips underneath here. We'll be able to see those better in a second. And now I've got force sliders because I can control the width of the integration along the x direction and along the y direction. So I can take different slices of this thing here. And so you can see underneath there, I've got all these Riemann strips underneath there. Looks like a whale's mouth or something under there. But you can again get an idea of how much each of these strips is contributing to the integral, because I just passed over the peak in the function there, and so that's going to give me a pretty significant change to the integral. But once I get into this this dip in the middle here, I'm not going to get as big a change in the integral. So let's try to get this thing divided into quarters here. There we go. I've got that nearly divided into quarters here. So now you can see I don't have that big of strips in here, so I won't get as big a change to the integral. But it just helps you see, what's going on here when you've got a two-dimensional integral going on. A lot of the times we like to just jump directly to this integral being the volume underneath this thing, but that's not necessarily the only application you have. You want to think of these integrals as being summing up tiny pieces. This works the same way as the last one we saw in the previous episode. I've got my range here for x-min, y-min, x-max, and y-max. We've got our function now of two variables, so your function needs to be a function of x and y. Here's where we create the cells. I'm doing a little flip-flopping around because VPython has x going to the left and right and y going up, and I want y to go in and out of the plane, or in and out of the screen. So I've just switched x, y, and z here. You don't need to worry about that. There's not really anything different to do with that. But we go through the same process of updating the cells. It's just got a little bit more to the Boolean here, where we're checking for x to be between its minimum and maximum, and checking for z to be between the y-min and the y-maximum. And of course, we've got 4 sliders set up now instead of just 2, but it works pretty much the same way, and it's a nice little demonstration of how integration, it really is the same in 2 dimensions versus in 1 dimension. It's just a question of how many passes you're going over. So you can use this to visually see how you're doing with your integrals here in 2 dimensions. Let's go back. Let's try a different function. Let's see. Let's try sine of x squared. Let's see. We had to do this as 2 times x last time, so let's go ahead and do that. Times sine of 2 times y squared. Let's try this one. This will give us several peaks, I believe. Yeah, ooh, this is very interesting looking. Yeah, let's zoom out a little bit there. We might need to decrease the step size on this one. But let's suppose we decrease y max, so we peel it back this way a little bit. You can see where the peaks and troughs are coming in. And what's neat about this is because you have this little cross section, you can see that you always get a sinusoidal curve along here. It's just a question of what its amplitude is, right? So we can have bigger amplitude, smaller amplitude, back up to a bigger amplitude, because you're only looking at it along the x-axis here. So that's pretty cool. Let's see what happens. I believe you get the same thing if you change one of these to a cosine, but let's just see what difference that makes. Yeah, it's basically the same thing. I think it just changes the location of the peaks and the troughs. But anyway, I hope this is useful to you. If you're learning about integrating in multiple dimensions and that's getting a little confusing for you, you can put in your function there and then change your bounds here and see how your integral is changing down here in the answer. Next time what we'll look at is a similar code, but we'll look at how we do integrals in spherical coordinates.